Sorry. So I was saying thank you to Alexander, and yeah, apparently I was muted, so I will repeat. We don't have much time for questions. If there is any question, you can put them on the chat, of course. But with that, I would like to thank you, Alexander, and welcome. We'll close this session here, and then we start with the last session, which is testing. And well, it's quite important to test wind turbines, as we have experienced, because at the end, every manufacturer that comes in the market, it's a business card for the industry. And if a product doesn't work, then the whole industry is perceived as doesn't work. So to also show a little bit better this concept, we have invited Otto Reinke, who has a business background, but he has founded a small wind company, TWE-Tandem wind energy. And we have invited him because it's about a year and a half that he is around Folkecenter with his prototype and he's testing his wind turbine. And now he will tell you about his experience with that. And just here. Yeah. Yeah, if you can put the presentation back.
I'm trying to do moving the mouse.
Yeah, sorry. Yes, thank you. Try to work. Yes.
Yeah, first of all, thank you very much, Dania, and for the invitation that I can give you a short presentation on the developing of our small wind turbine, especially here at Folkecenter, and the importance of testing. Maybe a short information about Tandem Wind. We are a small or young technology company coming from Hennigsdorf. It's close to Berlin. And we like to develop we call it wind turbine for everyone, because our vision is that everyone should have access to the clean and affordable energy. And with our small wind turbine, we'd like to support this decentralized energy production, as well as to reduce the individual CO2 footprint. Well, how have we started our development? Yes, we have not started in zero, I have to say. In the beginning, we have taken over the technology of a small wind turbine, which has been developed by SMA, Aerodyne, and ESIT. This is the Fraunhofer Institute, and that's the University of Kassel. And they, in the past, have developed a small wind turbine concept, and but due to different reasons, they have not continued it. And we, as Tandem Wind, have taken it over. And afterwards, we have started to optimize this technology in the field. By doing so, we were looking for test locations. And I can tell you it's not very easy to find the right location in order to test and optimize and develop a small wind turbine, especially also in Germany. So in the end, we found 3 locations, one in the Netherlands, one in Germany, and one here at the Folkecenter. And as Daniel has mentioned, around about 1.5 years ago, I was coming here and said, I have a big idea and a small wind turbine. How can we start? The Folkecenter itself has a long reputation, not only in terms of wind turbines, but also they have here a lot of facilities in terms of waves test station. They are doing a lot of things in terms of solar energy test centers, hybrid systems, but especially also for small wind turbines. And they have 2 test facilities, which different customers coming from abroad for testing rotor blades, for testing wind turbines can use here. The focus, therefore, also based on the Corona pandemic in the last years, has been here in Folkecenter, because the other facilities, it was quite difficult to get access to. At Folkecenter, what is very special here, what I found very, very good for us and for our development is on the one hand, the infrastructure. Everything is here. You have a test field, you have concrete plates, you have the connection to the grid, the measurement devices, you have wind speed measurements in different heights at 10 meter, 12 meter, 15 meter, so everything is there. And one special thing is we have a workshop. And I can tell you, if you want to develop a product, you always have to change the one or the other thing, and you have to work. And therefore, this machinery, which everybody can use here, is very useful for it's worth of gold to do this one here at Folkecenter. Additionally, there's a lot of know-how. I think Folkecenter has started years ago. We were one of the first worst NGOs in developing small wind turbines. I have seen some of the products they have developed here in the museum, which is also close here. And I have to say there's a lot of know-how and especially a lot of support. When you come here with a new product and a new development, and to have very fruitful discussion with the people, sometimes also with things which I don't like so much, but on the end, it was always convincing. And I think we have made a very good project here and with a very good product behind. And finally, we have wind. And this is essential for the development and also for the testing of the small wind turbines. If you go to Netherlands or to Germany, we have average wind speeds of, let's say, 5 meters. So you can make your testings between September and March, and then you can stop it because there is no wind anymore. Here at Folkecenter, we have around about 7 meters per second average wind speed. So it goes up to 20 meters to 30 meters in autumn and winter. For example, tomorrow we have a forecast 23-meter gusts. That means already it will be very nice for the next testing steps, which we have in mind. But even in summer, we had days with up to 10, 12 meters per second. So therefore, the environment for testing, continuous testing of a wind turbine are very well given here. Well, how have we started? In the first step, we have taken the original concept, which has been developed in the past by SMA and Aerodyne, and we took this concept and then we were looking for suppliers to produce it and to start a kind of production development. There is a difference if a product has been designed and developed by a university in a form of a PhD program, or you have to put it on a production line in order to produce it. So therefore, we started to build up our supplier chain and to start with them the production development. Here, for example, you see in the top left side, this was the original concept which has been developed, and below you see now which is the current concept of the generator and the machinery housing. So we are following a kind of single frame concept. That means everything, the generators, the gears, the shafts and everything is integrated in one aluminum casting housing. So it's completely protected and against the environmental aspects. And we have also changed the brake concept, but this is only some things, some items which we have changed. Then we have almost done the same thing for the tower. In total, we are having today a 12 meter, a 10 meter, a 12 meter freestanding tower and an 18 meter guided lattice tower. And we optimized on the one hand side, the tower in terms of productability, as well as in terms of static. We optimize the static of this one. So this tower is possible for wind class 1, for example. And then we aligned the elements of the 12 and the 18 meter tower. The elements are basic elements of 3 meters. We lined it in that way that we can configure with only 4 elements the different sizes. And we have even the idea to expand it with 1 adapter element more, to have always the same basic elements to have different configurations. And also we make it for easy transportation and commissioning. So we can put one element in the other. In the end, we have a length of around about 3 meters. So with a trailer of 3 meters, I put the tower on, then I have the nacelle in the car. And with my Vito and a trailer, I can bring these wind turbine to every place where I want to. And it is easy to commissioning the wind turbine because you don't need a crane. You can do it by manpower and by human power only with a mechanical winch. I did it quite often in the meantime here at Folkecenter, so the people can prove it. In the meantime, in half an hour, I bring the wind turbine down and I can bring it up. Which is also, for example, if you have very heavy storms or hurricanes, in worst case, bring the wind turbine down, fix it, and when the hurricane is over, you can bring it up, and it takes half an hour, and you have again electricity. We changed a little bit the machine housing and the nacelle, so therefore we also had to change the nacelle, and we have here a new design. It's a little bit special, I have to say, but we got very good feedback, especially here also from the Husum Wind, where we have presented our concept. It's a little bit more organic and a little bit less structural version, but we also make it in that way that we can use the sides of the nacelle for advertising and for promotion. Construction of the wind turbine. So we have asked then our suppliers to make the first versions. As mentioned, we have commissioned and directed the first 3 wind turbines. You see it here, how we have done it at the Folkecenter. As mentioned, here it was round about 2 days which were necessary to erect this wind turbine. And as of today, we make it in half an hour, bring it down, then we can do what we want, repair, change blades and so on, and bring it up again afterwards. And then we started testing. And here we had some challenges because the original concept was a downwind concept with protruded rotor blades. So the rotor blade itself were a very soft design because the idea was the stronger the wind is, the more, due to the low stiffness of the blade, the more the rotor blade is bending and the less for a load can be on the rotor blade itself. So the idea was that this concept can assure that it will survive 65 meters per second wind speeds. The problem which we are seeing here was, on the one hand, the bending, because if it bends to the one side, it also can bend to the other side. And the second point, what we also faced here is a downwind concept is always facing a tower shadow. That means we have wakes behind the shadow, behind the tower. The rotor blade is going into this wake and it's creating a kind of helicopter sound. And it was a challenge. We really did a lot of things, but this is what we have faced. On the one hand, due to the bending of the blades, we had a tower contact. And on the other hand, as mentioned, we are facing noise. In order to overcome this development, we have started a very intensive testing and development phase. In total, we have tested 5 different rotor blade profiles. We have protruded rotor blades, we have twisted rotor blades. We tested it in upwind and downwind. We had different tilt angles, different cone angles. We had different materials. We have tested it in wood, we have tested it in GFK. So a lot of things have been done here before we have come to the final solution. And we came then to a rotor blade. This is a NACA profile, which we finally have selected because of a very good performance and it's not very noisy. So then you have your rotor blade, but what is the next step? Of course, there are legal requirements for testing a small wind turbine. So that means we have to take the next steps. One was, for example, due to IEC, static blade test. And this we have then also fulfilled. And we did it yesterday, and we had a big audience, and we put there our 200 kilogram on 2/3 of the length of the rotor blade. There was no cracking, no noise, no nothing. So therefore, we are very much satisfied with the rotor blade, which we have now selected. Noise. I mentioned it already, noise in terms of downwind concept. Finally, we have decided to go away from the downwind concept and to make this product as an upwind wind turbine. In order to do that, we were testing different technical solutions. One was with a wind vane, and the other one was with an active yawing system. As well as a free yawing downwind concept, as well as with a tested wind vane, we always have this kind of yawing moment on the nacelle. We saw it, and we thought, and we came to the conclusion in the end that it's not very good, because it's always a little bit going out of the optimal position of the rotor blade to the wind. On the other hand, it is also having a lot of fatigue impact on the rotor blade, on the nacelle, on the tower and foundation. So therefore, finally, we have selected an active yawing system in order to secure that the wind turbine is always optimal to the wind. Here now you see a little bit the final data sheet. I will not go through in detail in this one, but only maybe in general. We have 2 stages, asynchronous or induction generator with 1.5 and 5 kV. 5 kV. Starting point is, or cut-in wind speed will be 3.5 meter, rated speed 11.5 meter. But this one, due to the 2 stages, is optimized in the middle area of wind speed, let's say between 6 and 8 meter per second. Rotor blade itself, we have a diameter of 5 meters, so 2.5 meters, one rotor blade. The length, we have it in wood. With this configuration going to the market, we see also quite a lot of customers, at least we got the feedback from the fair about it, who are interested in, from an ecological point of view, in wood, but we will also make it in GFK later on because of cost optimization, which we are targeting. The generator itself and everything, generator gear, everything is housed in the single frame concept. The tower, as mentioned, 10 meter, 12 meter, and 80 meter. This is a concept, how it looks like today. We have started the marketing activities already in last week. We have been at the Husum Fair. We were there a little bit, the exotic company, I have to say, because there, I think there was one vertical axis company with a vertical axis wind turbine, but we were one of the, we were the only small one. Enerkite for this was another company, but we got a very good response and feedback on this. And you see here on the picture a mock-up of the wind turbine, how it looks like in the end. And this was, as mentioned, the official marketing start. So now we are starting the distribution of our products, and we are looking for sales partners, we are looking for distributors, wholesalers, and especially for around about 10 lighthouse customer in order to have a certain product in the market for testing, for long-term testing, where we want to bind the customer very close to us in order to monitor the behavior of the wind turbine in the next months and years. So that is more or less a short overview of what we have done in our development process. Yeah, we have still done other things. We have tested different earth anchors and different foundation possibilities. So a lot of things has been done. It gives only a short insight. And I can say that when at Folkecenter, we have a very good place now. We found it very good because of the infrastructure, of the people and the know-how which is available here. And I can recommend everyone to come here and to see what is possible when you have, what we can develop when you have a good environment. So questions are always welcomed. No question? Good.
Have been clear.
Okay, that's fine.
Thank you, Otto. Yeah.